All right, boys and girls, period 2, period 6. This is Mr. Trutna coming to you live, even though I'm not live. I am alive, but I'm not live. This is a recording of me, and this is Math 1. We're going to start Unit 10 today. Unit 10, Section 1. We're going to be going over counterexamples. Once again, don't freak out. You're listening to Mr. Trutna. That is I. And this is Clovis High School. Wake up, Kylie Delk, Caden Gonzalez, pay attention here. So you should be actively taking notes right here. Your teacher has just handed you out the piece of paper that looks very similar to this piece of paper right here. This is going to be your notes, okay? So you should be actively writing down notes as I write them down here. And what we're going to be doing today is we're going to be defining what a counterexample is. So we're going to be defining the word counterexample, and then we're going to be going over how do you come up with a counterexample for a statement and for each one of these particular statements, okay? So what is a counterexample? So let's start off with that. That's going to be our focus today. So a counterexample is an example that shows a statement to be false. Counterexample. Definition. An example, I can spell example, thank you very much, Connor. An example that shows a statement to be false. Okay? So what we're going to be working on today is we're going to be using what we call inductive reasoning. Okay? So you're going to hear me mention this word, inductive reasoning. And what that means is just means that we're going to be using basic reasoning skills, a basic thought process, and we're going to be coming up with an example. That means one example that shows a statement to be false. Okay? So let's just do one really simply up here in our notes. Then we'll do letters A through E. Okay, so let's say that I come up with a statement today, guys, and I walk into class and I say, all right, guys, here's the deal. All states in the United States of America start with the letter C. Okay? California, Colorado, Connecticut. And I go, every state, all the states in the United States of America start with the letter C. That is my statement. Okay? If you are an educated person, would you hear that statement and use inductive reasoning, which means would you use a basic thought process relying on knowledge that you know to say, hey, wait a second, Mr. Trutna, I don't think that is true. Okay? Would you do that? Yeah, hopefully you would. And so if you say, wait a second, Mr. Trutna, that statement's not true, what you are doing is you will come up with a counterexample, which would be an example that shows that this statement to be false or is false. Okay? So if I said, hey guys, true or false, here's my statement. All states in the United States of America start with the letter C. You would hopefully say false. And then I would say, okay, well, what would be a counterexample of this? Okay? To come up with a counterexample, you would use what is called inductive reasoning, which means that you would use a basic thought process and rely on previous knowledge that you have. Okay? So give me a counterexample, you guys. In other words, is there a state that does not start with the letter C? Alexis, Could you possibly think of a state that starts not with the letter C? Kenny, what about you? Good. I don't know if you guys heard, but ironically enough, Alexis and Kenny said the same exact thing. They said Alabama. Alabama is a state. Okay? Is a state not starting with C. Okay? Not starting with C. So, that would be an example of a counterexample. Okay? Now, notice a counterexample. It's an example. It's just one example that shows this statement to be false. All right? Are there more states that don't start with the letter C? Absolutely. There's actually 47 states that don't start with the letter C. There's only 3 states in the United States of America that start with the letter C. California, Colorado, Connecticut. All the other states start with some other letter. So, would Alabama be the only counterexample we could have come up with? No. We could have come up with anything that did start with the letter C. Alaska, Arizona, Arkansas, Delaware, Florida, Georgia, and so on. Any one of those would be a counterexample, okay? All right, so let's go through parts A through E. What is a counterexample for each statement? Okay, so I'm giving you a statement, then you guys are going to come up with a counterexample for each statement. In other words, we're going to think of an example that shows a statement to be false, okay? So if a person is a professional athlete, then they play football in the NFL. Okay, so that's my statement right there. Now, is that statement true or false? Okay, so hopefully you're using inductive reasoning. And remember, that's just basic thinking skills relying on prior knowledge to come up with a reason. Okay, so is that statement true or false? Well, that statement is false. Okay, if a person is a professional athlete, then they play football in the NFL. Okay, that's false. So give me an example that shows that statement to be false. Counterexample. All right, how about this one right here? Counterexample. Stephen Curry is a professional athlete. Hopefully you guys all know who Stephen Curry is. If you don't know, he does not play football in the NFL. Stephen Curry is a professional athlete, comma, he plays basketball. All right? And hopefully, since you're hearing this on Tuesday, the Warriors are up 3-1 on Tuesday because they play Monday night. And I'm making this video on Monday. I know, Ryan Christensen, it's hard for you. Wait a second. How is Mr. Trutna making this video on Monday, but I'm listening to it on Tuesday? Mind-blowing. I know that. Good. Caden, you got it. Yeah, mind-blowing. Right, Natalie? Good. But that would be a counterexample. Now, is that the only counterexample? No. You could come up with any example of somebody who's a professional athlete who plays some sport other than football. Okay, you could have said Bryce Harper. He plays professional baseball. I don't know. Josie Altidore plays professional soccer. Tony Hawk, he's a professional athlete. He plays skateboarding. He rides skate. He doesn't really play. I guess he skateboards. Okay, but anything. All right. B, if a polygon is a quadrilateral, then it is a square. Okay, so let's think about this. Let's use inductive reasoning. So this is saying, if a polygon is just a shape. This is saying, if a shape is a quadrilateral, then does that mean it has to be a square? You should be saying to yourself, no, that's not true. Just because a shape is a quadrilateral, that means it has 4 sides, does not mean it is a square. Okay, so a counterexample to this would be, and this is not the only one, but a counterexample would be an example that shows this to be false. Okay, so a counterexample, what would that be? A rectangle is a quadrilateral that is not a square. Okay, that is not a square. All right, guys, so that would be a counterexample of that. All right? Okay, C. When you multiply a number by 3, the product is divisible by 6. Okay? So, what would be a counter example of this right here? Now, if you don't know what this means, you have to do inductive reasoning, which means you're going to just use basic thought process, relying on prior knowledge to figure this out. So when you multiply a number by 3, so let's pick a number. Let's see what this means. So let's pick a number, all right? How about 7? When I multiply 7 by 3, well, that equals 21. Is that product, 21, is that divisible by 6? Divisible by 6, question mark. The answer is no. Lo and behold, I just came up with the counterexample. Okay, so the counterexample would be 7 times 3 equals 21. 21 is not divisible by 6. The word divisible, if you're not sure what that means, it means that it divides into. So 21 is not divisible by 6. Okay? All right. D, we've got 2 more to go on these. Hopefully you're getting the idea. So angle 1 and angle 2 are supplementary. So one of the angles is acute. Okay, so we have to use our inductive reasoning. Once again, inductive reasoning means we're going to use basic thinking, relying on prior knowledge. Okay, so what does that mean if angle 1 and angle 2 are supplementary? All right, so that means that, remember, supplementary means that the 2 angles add up to 180 degrees. So when we're saying they're supplementary, we're saying angle 1 and angle 2 are going to be equal to, when I add them up, they're going to be equal to 180 degrees. So this means that one of the angles is acute. Okay, so what does the word acute mean? Well, remember, acute means less than 90 degrees. Okay, so if I have these 2 angles and they add up to 180 degrees, does that mean that one of those angles is going to be acute? Okay, so let's see. Well, if I pick a number, how about this right here? How about if I pick 90? What would I add to 90 to make it equal to 180 degrees? Well, that'd be 90. All right, so are one of these angles acute? Whoa. Lights went out in the city. Got to pay rent more often. All right, okay, I'm back on. So, are one of those angles acute? No. Are those angles supplementary? Yes, they are. They add up to 90. So, I just came up with a counterexample. Okay, so my counterexample would be this. 90 plus 90 is supplementary, but neither angle. I can spell neither. Alexis, knock it off. Shannon, knock it off. I know how to spell. 90 plus 90 is supplementary, but neither is acute. Okay? Both of those are right angles. So there's my counterexample. That's an example that proved this to be false. All right, last one. The sum of 2 numbers is greater than either number. Okay? So this means that if I take 2 numbers and I sum them, sum means I add them, so this means I'm going to take some number, I'm going to add it to another number, and what we're saying is that's going to be greater than either one of these. It's going to be greater than the first number or the second number. Okay, well, let's try to come up with this. All right, so that means, like, if I take the number 2, I add it to some other number, let's say 7, well, that's going to be equal to 9. So that's equal to 9. Is 9 greater than both of those numbers, either of those numbers? That answer is yes. That's not a counterexample. So we have to try to come up with an example where when I add up 2 numbers, whatever my sum is not greater. Okay? So here would be a counterexample of that. All right, and I think the easiest counterexample would be this right here. Incorporate negative numbers. So for instance, 3 plus -1. So there's two numbers. I'm finding the sum, okay? Well, that equals 2. 3 plus 1 is equal to 2. 2 is not greater than 3. Okay, it's smaller than 3, is not greater than 3. So there's a counterexample. The sum of two numbers is greater than either number. That's not true. Here's the sum of two numbers. It's 2. That is not greater than either of those. 2 is not greater than 3. So that would be my counterexample. Okay, so what you guys are going to do is you're going to be given a worksheet now. You're going to be working on using inductive reasoning, and you're going to be creating counterexamples. Okay, that worksheet for you will be due on Wednesday when I'll be back.